So what that the projectile motion under the gravitational field, if you throw any of the thing, so it is going to be follow a parabolic path under the influence of the gravity. So it is going to be follow some kind of the projectile motion, something like this. This is the idea. But right now it is not being thrown from the ground. So we are going to be launcher is at the some height and we are launching it like this also. So first I am giving the just a theory, initial theory. You can skip for this part if you have the knowledge of that one. But I have to clarify a few of the things from my side. So what you can do is, so yeah, let's suppose you are throwing with the initial speed. So I'm going to call it the initial speed is u naught. In the whole projectile motion, to understand that one, we resolve the component of the velocities in the horizontal direction and the vertical direction, even not only velocity. So we had to be look this whole projectile motion in the two dimension as they suggest, and we are going to be every component as it is a vector quantity, any of the vector quantity we are going to be resolved into the two component. One is horizontal, one is vertical. So this is the initial velocity that they given v naught. We are going to be resolved that one. So this is, let's suppose that the theta we are going to be resolved. So you must know how resolution of the vectors also. So this is the theta angle. So if you resolve the v naught, it come out to be in the horizontal direction. Let me call it, this is the x, this is the y coordinate axis. So this is in the horizontal direction, it come out to be u naught sine cos sine theta. Cos component is come out to be because this is adjacent side. So if I had to make it this one, so this is the adjacent side. So this is the u naught is the hypotenuse, and to find out that one you required u naught cos theta component. So, or you want to understand very well, so what you can do is, this is the u naught and this is the hypotenuse. To find out this theta is given. So to find out this direction, so let me call it, this is x. So you require, let me call it, this is y. This is y. This is hypotenuse is known to you. You can think it like this, the vector u naught, we are going to be split that. So this is simply come out to be x. So let me write it, the cos theta. Cos theta is adjacent, x divided by u naught. So from there, x value is come out to be u naught cos theta. And in the similarly, so you have to use the sine component. So if I'm going to use the sine component, opposite by hypotenuse. So opposite is y by u naught, and then y component is come out to be u naught sine theta. So this is the basic idea. So you had to be keep in the mind for a moment that if you have, this is the y component, that is opposite of that, it's the u naught sine theta component. So if you have the component, so this is the same as v, this is the x. So I'm going to write like this, x component, in the same way we have the y component. So this is the y component that we have it. If the student is already aware of that one, they can skip that part, they can move further. So right now, this is the basic idea that I introduced that one. This is the x component, horizontal x component, vertical component of the velocity. We are going to be split that. Now, let's look into the acceleration, because acceleration is a vector quantity. We are going to be looking into that. So just think it like this. For a moment, let's suppose the ball is here. So you throw the sphere. So right now, sphere. So at this point, now just think it. Okay. Now what you have to think it. So in right now, the only gravitational force is acting on that. There is no other force. And the gravity, as we know that, it is going to be vertically downward force. So the force of the gravity is acting downward because the acceleration due to the gravity is always downward. It doesn't matter the ball is going up or the down. It's a constant velocity, constant one in the vertical direction. So I'm writing ay for the vertical acceleration. It is minus 9.8 meter per second square. So this is our minus g value that you can write it. So this is vertically downward at any point it is have that. Is it any kind of the most of the time we have the confusion that is it any kind of the acceleration in the horizontal direction? Is it you had to ask that question, is it anyone is applying that force in the horizontal direction at this point because it is already being launched? So nobody is applying the horizontal forces to this point. So the point here is that you have to keep in the mind is, so in this direction, there is no acceleration. Nobody is applying the force in the horizontal direction. There is no acceleration in the horizontal. This is the most important thing. So that is no acceleration that you have it in the horizontal direction. So there is only a vertical acceleration. So if there is a only vertical acceleration, because acceleration is the rate of change of velocity, so only the vertical velocity of the component is going to be changed, not horizontal component. Why? Because the horizontal in the horizontal direction acceleration is zero. Nobody is applying that the force in the horizontal direction. That mostly the student asks that why the ball is moving in the horizontal direction if it eventually it is nobody is applying the force to that. So it is moving because of inertia. It had the inertia, Newton first law. So inertia, the ball had the inertia. Due to that, is going to be moving in the horizontal direction because every time your gravity is attracting it, pulling it down, so it is going to be go to some height because somebody is attracting it. It is going to be fall down. But in the horizontal direction, the horizontal velocity component is not changing. So at the ball is here, a ball is here. Let's suppose that I show you the some of the points. So this velocity component is going to be remain the same. So this is u naught cos theta. Again, I'm repeating why it is not changing. At the peak value also, it is going to be remain the same direction. It is not going to be changed. So it is not going to be changed. It has the same. So hopefully that you have understood till now. So the horizontal velocity component is not going to be changed right now. Only the vertical velocity component. Now, to understand the vertical velocity component, you can think like this. You are throwing the ball upward. As you throw the ball upward, it is going to be have the some kind of the to understand the vertical velocity component. Just thinking like this, a ball you are throwing in the vertical direction, but eventually you are throwing the ball with the some angle only. But right now, because we split the component, just think it like this: one ball is going in the horizontal direction, one is vertically. They are nothing to do with each other. Their motions and their accelerations and the displacement are independent upon each other. So right now, if I had to briefly, so let's suppose that the ball, so you can think like the vertical motion, just if it had the initial speed something. So as you launch this, let's suppose I fire it, is going to be attain some maximum height. At the maximum height, the velocity is become zero. At the peak value, it is going to be take some time. So at the peak value, vertical velocity becomes zero. That I want to try to explain to you. This is the same case as you launch a ball vertically. At the vertical is the horizontal velocity component is going to be become the zero at this point. So as it going to become down. So this is the basic idea is. So the idea is, so at this point, so the u naught sine theta component, it is going to be decrease. It is going to be decreased. So it become u naught y component, the velocity is going to be become zero. at this peak value, because eventually the ball is not going upward right now. Vertical displacement is not there, so eventually the vertical velocity component, the peak value, is going to be become zero. To then, as it will come down, the vertical velocity, because of the gravity, it's pulling it down, so the component of the vertical becomes same at the same height. As it's going to be at this height, it will remain the same due to the symmetry. Obviously we are neglecting the air resistances in these cases, so teacher will never mention it in our courses. They are never going to be mentioned any kind of the air resistance in the projectile motion. Otherwise, the things become more complicated to solve it. So this is the basic idea of the projectile motion that we have it to understand that one. So right now, okay, so this is the basic idea that I given to you till now. So okay, now as I suggested you, you had to look into the whole projectile motion with some kind of the components split, basically horizontal component, vertical velocity component. And now if I to show you the projectile motion, now I will try to explain you. This is, you are launching the ball or a sphere with some specific angle. So, and as you launch it, so it is going to be follow some kind of the projectile motion that you can follow. This is the how they have shown it. If you look at the red bars, these red bar, it's just simply indicating that the component of the velocity, it is not changing. It is as the time is spending, so it is travel the same horizontal distance or the displacement as the time will passes. So this is the basic idea. Let me show you with some different angle. So it is going to be go like this. If you look at this, these are same horizontal distances are the same. So if I had to launch it with this one, so you can see it more clearly now. So the horizontal line, the gap between the horizontal line are the same. It means per second, you can think it like this, the distance traveled, or per unit time, the distance traveled is the same. Why? Because the speed is remaining the same. There is no acceleration in the horizontal direction. There is only a vertical velocity of the component is going to be changed in that. So hopefully you get the till now the idea is. So okay, so in this case also, let me show you the first motion. So this is somebody has thrown it. As you throw it, this is the motion. So with some specific angle, 20 degree. So, and as you launch it, eventually you can think it like this. You are leaving the ball every time, because the ball acceleration on the ball that is acting it the same. So eventually, if I combine both of them, you can think it like this: the ball, because vertical acceleration for the each of the ball is the same, so eventually they are traveling, vertical displacement is the same. You can think it like this to understand it. So okay, so this is the basic idea for a moment. So let's continue that. Let's write it horizontal component. Horizontal and vertical component that you have to. First thing is it any kind of the force in the horizontal direction? You're going to be say, no, no force in the horizontal direction has been mentioned before, because nobody is applying the force in the horizontal direction as it will launch. Obviously, we are considering that as it being launched in the, there is only gravitational force that is vertically downward that is acting on that. There is no horizontal force. So the Fx horizontal force is 0. Due to the inertia only, the ball is moving, because the ball had the inertia. Initially, I had given the motion of the inertia. So due to that, it's moving. So acceleration in the horizontal direction is 0. And what is the velocity in the horizontal direction? It is always going to be remain the same. So the ux is equal to initial velocity that you thrown it, cos theta component. Let's write the vertical velocity, that I'm going to say it gravitational force. Acceleration in the vertical direction is minus z. So vertical velocity component, that is u naught sine omega. So that is the u sine omega t. That is initial. So I have to write it initial vertical. So I'm writing initial vertical velocity. You can write it with the I or something. So we note right now that I'm writing. So let me write it initial vertical velocity component of the ball. I means initial dimension. Okay. Okay. So U. So this is the basic idea, the component of that one. Now to most of the question to solve it, of the projectile motion. So what you can do is, if the time is not given, so you can consider right now at the peak value. You can use of the peak value. Okay. So at the peak value, at the maximum height, which velocity component is 0? Vertical velocity component is 0. Means basically the final velocity component is going to be become 0. And so you can make use of that one. So as the time taken to reach to the peak height, I'm going to call it t half, because that is the half of the total time period, and the half time is going to be reached to this one. So half. So the idea is, till now, most of the time we are going to be find out the time expression. So to find out the time expression, we are going to be make use of the vertical velocity component is 0 at the maximum height. Only there is a horizontal velocity component. So as we mentioned before also, we are going to be solve this whole projectile motion separately. Horizontal component and vertical component. Separately, I'm going to discuss about separately. Now we have the equation of the motions. You must aware of that one. So we have the equation of the motion right now to find out the final velocity, because the final velocity. So you can write it final velocity. I'm writing with the v. Let me write it with the v. Initial is, let me write with the u. So v is the final velocity component I'm writing. U is initial velocity component. I'm going to write with the x is the horizontal displacement. Y is the vertical displacement. Okay. So right now we are talking about the vertical. So all the component we are going to be take vertical only. Vertical velocity component we are going to be take it. So to understand that one, vertical velocity component that we are going to be taking. So why? So let's find out the some relationship first. So okay, so the at the peak value, as we know that one, so that is the vertical velocity component is 0. So final is, you must be aware of this equation, v is equal to u plus at. So I already defined what is in the vertical direction. So I'm going to write like this. Everything vertical component. Now, because you find out the vertical velocity component, so and this is vertical velocity component at the peak value at maximum height, this velocity component becomes zero. Horizontal velocity component become uh, initial vertical velocity component. Initial vertical velocity component is initially what is the vertical velocity component that you are throwing it? U naught sine minus g, acceleration is minus g in the vertical direction, not in the horizontal direction. So this is the time. I'm going to write it the half total for the total time period. It is a half of that one. So I'm writing half of that one. So now from there, if you rearrange, so the t time duration is come out to be u naught sine theta by g. And now the story haven't ended, because the time, this is the time you can use to find out the maximum height if you want. What is the total time? So this is the total, half of that one. The total is the double of that one, obviously. So the total time period, we call it, that is the time of the flight. Time of the flight is 2u sine theta by g. 2u sine theta by g component. So that is the time of the flight that we have it. Now, as you get the time of the flight, but right now, let's somebody ask you the maximum height. So you can make use of that. Height means vertical. So you have to think about vertical velocity component only, time you got it. So how much that time is going to be taken. So to find out that one, so to find maximum height, to find out the maximum height, I'm going to call it H max, maximum height. So basically the y component, you have to find out the y component. Initially, we can take it, the you are launching from the ground only. So that the vertical height, I'm writing that height. So hopefully you're aware of these equations. So let me write it for a moment. So displacement, or the change in the displacement. So delta S, I'm writing change the displacement is equal to ut plus half at square. But right now, as we are solving for vertical velocity components, so I'm going to write it change in the vertical direction, that is the y height only. And so the uy component, time has no component, obviously, it is a scalar quantity. So that is the time half that we are going to put it the values of that one. So that is half minus g, and the time of the time is t. You can plug into the values and to find out the maximum height. Vertical velocity component is u naught sine theta, the t half. So the t half is the, how much it is? U naught sine theta by z minus half z and t square, sorry. So right now this is u naught sine theta by z square of that. So if you solve this one, u naught square sine square theta by z minus gg will cancel out. This is half. And look at this. So this is the one, and you can think it like this. This is the x minus half x. So complete x minus half of that. You will get the half only. So x minus half x. So you will get half of x. So basically, it means that half of the complete one, the u naught sine. You do not have to be memorized as per our syllabus. You do not have to be memorize anything. So I'm just telling you the method to approach to the problems are eventually they can ask you the maximum height. So this is the way that we are going to be do that. So if you know the initial speed of the projectile, first you have to find out the time. For the time, you have to be use the concept that the vertical velocity component is zero at this point. So, and we use that one to find out the time of the flight, half time of the flight, and then we can make use of that one to find out the height, maximum height. And the other, the one more question generally they form it, so that is to find out the range of that, a range of the projectile that we have. A range is the horizontal displacement. So basically this is, we call it range. So this to this distance is the range. So how far it is going to be fall down the range. Right now range is horizontal. So we talked about the horizontal velocity component, only horizontal velocity component that we are going to be take consideration of that right now. So horizontal velocity, horizontal acceleration, horizontal velocity, so horizontal displacement. So these are the things that we are going to be take consideration of that. So to find out the horizontal uh, this one, so let's talk about the horizontal one. So the you can make use of the equation again as delta S is equal to ut plus half it is. But interestingly, so let me show you. So this is, I'm going to call it the range, the delta x, or you can write it, this is the range of the projectile, x component, the velocity. So this is the horizontal acceleration. What is the horizontal acceleration? Continuously we are discussing about that horizontal velocity acceleration is zero. So there is no acceleration in horizontal direction. So the range is come out to be, so how much the range is come out to be? So the range is come out to be, this becomes zero. So this becomes zero. I'm not putting that. Initial horizontal component is u naught cos t. Time you already find it out. This is the double. So you have to take it this time of the flight, the complete one. Otherwise you will get the half of that. Cos theta, sorry. So let me first write it. This is ux into t, and t is the total time period. So let me write it the range. Double, sorry. So it is u naught square 2 sine theta cos theta by z. And if you know the trigonometry formula in the data booklet, they will provide to you to use sine theta cos theta, that is sine 2 theta, double angle trigonometry. So this is sine 2 theta by z. So this is how you can understand the projectile motion. Usually in the examiner, they mostly talked about the different angle, at what angle, at initially what the height is they are being launched. But the whole concept of the projectile motion can be understand easily with to considering the horizontal velocity and vertical velocity of the component separately. So this is the basic idea that we required. So this is all about for a moment that the derivation. So if you had the any of the doubt, please leave the comment. Yeah. So I can try to make the more videos on problem solving eventually. But this is the basic idea. They are the 3 to 4 type of the questions they generally ask it. So as per the information that they given it. So initially the time of the flight, we had to always find it out. We must know that eventually, otherwise we are not going to be solve any of the question. Time of the flight, we know that. We had to find it out mostly. Most of the questions are. And then maximum height, the projectile can go, the range it can go. Initially, they can give the maximum height of the projectile. They can give you the time. From the time you can relate the things are. So they can ask you the initial velocity component, and accordingly that you can make use of that one. So this is all about the projectile motion. So this is all about projectile motion, that we can stop a video right now.